So yesterday we talked about a couple of things. The first is we discussed the history of AI, right? So the history of AI spans all the way back to the 1700s when, we created a fake chess-playing robot that fooled everyone in Europe. And then, fast forward 200 years to these set of gentlemen here who founded the field of artificial intelligence at the Dartmouth conference in 1956. That led to the first AI summer, whereby we essentially used logic as well as a bunch of rules, actually the rules in the second AI summer, to create fairly complex programs, right? Programs that we actually ended up using in medicine as well. And then there was another AI winter in the 1990s and the 2000s before the invention or discovery of the neural network. The neural network itself was actually created in the 1990s, but computational power wasn't powerful enough to use these yet. And so in the 2010s, we started having enough compute for this to kind of work. And then, we had kind of another mini AI winter before moving on to the transformer, which led to the creation of ChatGPT and kind of AI as we know it now. And so we've seen a lot of progress with things like reasoning models as well. And so we'll talk about some of the progress today. Now, we discussed the neural networks and how they're basically just a representation of a basic logistic regression problem and kind of stacking more layers. And so, with logistic regression, you have a bunch of features and you basically have a bunch of coefficients which correlate to the features. And then you're trying to predict a certain output, right? So for example, in this case, the length of stay of someone at a hospital. And so the neural network is just simply a way to put this problem into kind of a graphical format that's easier to understand. And so people experimented with adding a lot more layers as well. And we also discussed things like loss functions, which is, once you have a prediction, actually calculating how wrong you might be, and using this concept of the loss landscape in order to kind of visualize what we're doing with AI. And so the goal of AI is to essentially find the part on this loss landscape where the loss is minimal, because this is where AI will do the best. Now, AI, as we kind of discussed yesterday, can't be perfect, right? As you can see here, the loss is not zero, right? It's not like AI is always perfect. But what we're trying to find is this global minimum. And so kind of the field of AI is trying to find that global minimum throughout a very advanced loss landscape. Now, we also discussed the universal approximation theorem. And it's this really powerful theorem that proposes that a neural network with at least one hidden layer and a non-polynomial activation function can approximate any function. And so people have actually shown this in empirical research. So, say you have a function that looks like this. A neural network over rounds of training will eventually learn how to replicate exactly that function, right? So kind of very powerful stuff. Now, we also discussed transformers yesterday. So transformers are essentially neural networks. So neural networks which provide the ability to model any mathematical relation, plus this new concept called attention, which is the understanding of the surrounding context. And so we discussed this example here, whereby depending on how you use the word light, it actually modifies the understanding or the meaning behind that word. So say, for example, we have the sentence, turn on the light. Attention basically updates the mathematical coordinates of light so that it means something different to if we had light on your feet, whereby light would be updated or pulled down towards the words that it's surrounded by, right? So so it's kind of cool in that we're basically now using this concept of attention to update individual words based on words that it's surrounded by. We also discussed the 5 different steps of transformer training. So the first one is that because transformers can't deal with words, right? They prefer using tokens, which are subwords. We need to tokenize everything that it sees, so everything that it inputs and outputs. The second step is something called pre-training, which is we basically mask a bunch of words and then ask it to predict what that word is, right? And so there's 2 different ways to do that. The first is through BERT, which is like a cloze exercise where we mask different words in a sentence and then ask it to predict it. The second is through GPT, which is we mask the entire sentence after the first or second word and then ask it to predict it. So it always is predicting what the next word is. This is completed at scale on the internet. And so very, very powerful technique because it's unsupervised. So we don't need to do anything. We just need to hand it the internet and then it will learn quite a lot. The third step after that is that we need to do something called instruction tuning. So at the point in time in which we pre-train, the model's kind of useless, actually. So if you ask it to do something, it doesn't know how to do anything, right? And so you need about 100,000 pairs where you ask it to do something and it provides a useful answer, in which case we train it using fine-tuning. And then from there on, it becomes very useful and it becomes what we call an assistant model. So that is, it can actually answer questions that we ask it. The fourth step is we then do this thing called alignment, which is we ask a bunch of users which answers they prefer. And we're basically kind of just fine-tuning the model, kind of improving the model bit by bit so that it can learn how to actually answer based on our personal preferences. And then step 5 is simply running the model, which we call inference. Okay? So those are the kind of 5 steps to create a transformer. Okay, so yesterday we discussed these topics. And today we'll actually be shifting a little bit to what's been happening right now in AI. And so we'll be covering a number of topics like how to think about AI, how to actually use AI, right? Like how to think about different models that are around. We'll be talking about novel architectures, so what people are currently thinking about how to improve models right now. Novel interfaces, so how people are thinking about interfacing with AI. There's lots of kind of new interfaces that have appeared this year. We'll be talking about AI agents, which is one of the hottest topics of AI this year. AI models have gotten really powerful, and so they can actually search for information, find information, reason through information, and also kind of deal with different interfaces. So very powerful stuff. We'll then kind of end on a lighter note, which is talking about how people are thinking about AI interpretability. So how do you actually think about these black boxes, right? And then we'll also be discussing some kind of fun examples in AI security, which is how you can actually break these models, as well as discussing kind of a recent hack we were talking about yesterday, where some actors from China actually managed to use Claude in a very powerful way to hack into American systems. So some very cool stuff. Okay, so let's talk about how to think about AI. So how should we think about AI? So AI has become a very powerful technology, and there's lots of ways of framing this kind of new technology. Now, the first one is, and hopefully we're all familiar with, is that AI is a very powerful prediction and generation tool, right? So in terms of generation, large language models are very powerful, for example, for generating new pieces of language, right? So you can ask it, for example, to write a poem, and it will be able to do so. It's also very powerful for generating things like images or videos, right? And so hopefully you've kind of seen AI-generated videos or images and just kind of notice how realistic it kind of seems, right? How much quality there actually is in the image. Even 5 or 10 years ago, we could not imagine that this technology would exist today, that you could actually generate this kind of stuff, right? It's not limited just to language and videos as well, but it can also be used, for example, in biological domains, right? So people are using AI to generate, for example, new proteins or new kind of genetic sequences, right? People have started to see if they can generate new drugs with it as well, because we have lots of data on this content, right? And so you basically just need to train a large, not a large language model, but a large protein model or a large genetic model, right? So there's lots of companies that are trying to enter that space and see if they can, speed up drug discovery or kind of invent new drugs that we didn't think were possible, right? So kind of very cool stuff happening in that space as well. The second concept is that when AI actually does this extensive close exercise stuff, like it's trying to predict what the next word is, it actually develops a good understanding of the world, right? If you ask it for, what is the definition of this disease or this concept, it actually has to somewhat understand that concept in order to be able to explain it, right? And so kind of a second frame of mind to have when thinking about AI is it's a very powerful world modeling tool. So obviously, being able to predict something requires a very rich and detailed understanding of what you're trying to explain. And so companies like Anthropic, and we'll talk about this in a bit more detail later, have actually looked into their models. So Anthropic's kind of one of the major AI companies that we have around now. And they have found neurons that understand, for example, the concept of the Golden Gate Bridge in many different ways, right? So this neuron will always light up when you talk about the Golden Gate Bridge in English, this looks like Japanese, in Korean, in Russian, right? So even if you refer to the Golden Gate Bridge in different languages, the same neuron will light up, right? So kind of a very cool concept. It's also the same if, for example, you have images of the Golden Gate Bridge. That neuron will light up as well, right? Meaning that these models actually have a unified kind of understanding of what the Golden Gate Bridge is, right? It understands it in different languages. It understands it when it's provided an image or video of it, right? And so it actually has kind of a deep understanding of different concepts, right, as it sees the world. And part of that reason is because AI is able to draw kind of much deeper connections than as humans we're used to, right? Like it can not only draw like things like primary and secondary connections, right, but also things like tertiary or quaternary or kind of nth level connections. It just keeps on going deeper and deeper. Anthropics also released a couple of interesting, I suppose, like slides from when it looks into medical concepts. And so this is a map of how different neurons in the system interact. And you can see how there are things like common diseases are basically grouped together, right? Things like immunocompromisation is grouped together. Things like autoimmunity is grouped together. Even things like vaccines and immunizations. And I kind of cut it off, but the concept of legal immunity is somewhere here, right? So it's kind of further away, but it understands that it's somewhat related to immunity, right? So very cool that you can reach into these systems and kind of see how they see the world, right? And it's a very kind of rich understanding of that world. Now, there's some pretty cool things that Anthropic has demonstrated as well, which is that it's possible to up or down adjust different connections or features. And so I mentioned before that, for example, they found a neuron that correlated to the Golden Gate Bridge across different languages, across videos and images. And so if, for example, they reach into kind of their models and find, if you ask, actually, sorry, they found a neuron for brain sciences, right? Now, if you ask the model, kind of like a default model, what their favorite science is, the answer is physics. But if you reach into the model and find this brain sciences neuron and then multiply it by 10, the answer actually updates to neuroscience, right? So very cool. So you can kind of reach into these models, 10x, for example, certain neurons, and then completely modify the behavior of the model, right? So very cool stuff. Now, I don't have the slide here, but they actually had a kind of fun one where they reached into the model, found the Golden Gate neuron, turned it up by 100, and then they asked Claude what its name is, and it thinks it's the Golden Gate Bridge, right? So it's kind of interesting to see, right? And so, I kind of see stuff like this, and I kind of think if these models, have any semblance of consciousness, because can you really reach into someone, to crank up a certain neuron, and then suddenly they think there's something completely different, right? Kind of weird to see how much we can manipulate these models. Okay, so I'll talk a little bit more about that concept later in the talk. Now, another kind of useful thing is that if these AI models have a good and deep understanding of the world, can we actually use it for hypothesis generation from a scientific standpoint, right? Because these AI models might understand a lot more than we might see ourselves, right? And so this was a kind of interesting study recently whereby someone built a foundation model or a large model for cells, right? So they uploaded a lot of cellular data into a model. And they basically pulled out what these models were seeing. And what they actually found was that, for example, there was like an island of cells which they had not identified yet. So it was a set of cells that we had not kind of known about, right? And another kind of island that they found was a set of cells that had only just been discovered the year prior, right? So it was kind of like a new cell in the kidney that we had not understood and known about, but it had its own little separate island, right? And so therefore didn't really fit any other cell, right? So these kind of language models or large kind of transformers might actually understand more about the world than we understand because they're able to draw these connections. So kind of very cool from a scientific standpoint as well. All right, concept 4. Now this is an emerging concept. AI has increasingly been seen this year as an agent, and we'll talk about what those patterns actually look like. But we're starting to see AI be able to think, search, and act. And so there's been kind of use cases whereby AI can reason through what it sees, search through different pieces of information. So for example, things like the internet or databases at companies, right? So kind of proprietary information. And it can also act on that information if you give it the power to do so as well. And these kind of insights have been surprisingly simple. And so I'll talk you through like what they actually each mean. But this is kind of added together into kind of very powerful AI experiences. So things like, I don't know if you've experimented with ChatGPT Atlas, but it's a browser that allows you to use AI at the same time. So you can, for example, ask ChatGPT to, buy you this list of groceries, and it will go to, the Uber Eats or DoorDash website and actually select those groceries for you, right? Now, this is kind of an innocuous use of AI, but you can imagine how you can do a lot more powerful stuff, right? If you just give AI kind of clear instructions about what you want to do. This is also kind of leading to advances in robotics as well. So when people connect large language models or large vision models together with robots, you can ask it to do things like, can you actually fill up this dishwasher for me, right? So kind of very cool use cases. But again, you can imagine in a military setting, for example, you might ask the robots to be doing a lot more than just stacking dishes, right? A kind of very powerful paradigm. So the kind of first reflection that I want you to think about is that with these kind of different framings, right? Obviously from the basic prediction or generation, but things that are more scientific like world modeling or hypothesis generation, as well as more practical like AI as an agent, what are interesting use cases for AI that you can think of? Ones that are kind of pushing the boundaries of what we can do now. So I'll give you 5 minutes and then we'll come back and kind of discuss. Okay, so what kind of use cases can we think of given these ways that we're framing AI? No from the second first.
Repeat the question once again.
Yeah, so kind of like thinking about AI as a tool for prediction, like world modeling, like hypothesis generation, or as an agent, right? What are ways that you can use AI kind of in interesting ways in medicine?
Thank you. In terms of epilepsy and seizures and things, I don't think there's like a distinct chart of like how much medication you provide the patient. I think it's very subjective and variable. So they could come up with like a tool where they analyze the trends between like, okay, this is the optimal amount for this body like structure or whatever. And then they could create like a chart.
Okay. Yeah. What do you think about Maya? I don't know. Okay. Yeah. So Maya's a neurologist, actually. Like, yeah. Yeah.
What was it, an epilepsy prediction model for?
Just like how much dosage fit for the drugs.
Oh yeah. No, that definitely would be great. I guess we know that the levels work in the individual, so better than they do as an overall, because the levels don't necessarily tell you whether it's therapeutic in an individual person. But once we know what your individual level is, we can help predict it. So maybe we could be smarter about that. Yeah, I like it.
Yeah. Awesome. Yeah.
About, I guess, because I work in a clinic, and then part of my role is to transcribe the AI, like to check over AI transcription of like doctor to doctor communication.
How good is it now?
So it's pretty impressive, but it still makes a lot of critical mistakes.
Yeah.
Like drug names, dosages, patient names, and like the sort of medical side. Obviously, it's still got a lot of work to go. But it's like, if I didn't do my job correctly, some patients getting the wrong drug. Or
you reckon you can use AI to be the person who to be the checker as well?
Possibly, but obviously it's like when a doctor is like saying their voice notes.
I have an idea just pop up in mind just for predictions. So nowadays, like hospital are focusing in like treating and when you got any disease or some kind of like disorders, cancers, and you give you treatment. For how about for unknown people, we haven't diagnosis for any diseases. There's a gap between that healthy person and people or patient that have diseases. So for that, what if we input our like blood report on any biomarkers or like MRIs into a model and give out a like health status or like a weight or like mortality or a health status of just a marks that can predict how healthy you are and how close are you to some kind of disease. I think that's interesting. Thank you.
Yeah, like that's kind of an interesting thought because one of the things is, like I feel like the body is like infinitely complex, right? So it's like, do we even have enough tools to measure all the stuff that happens in the body, right? Like, because even, I'm sure like everyone understands it, is like the blood tests that we have now are not great, right? Like they're not like that great, right? Like, you could probably have like 100 times more fidelity. Even I don't even know if you want that much like resolution even, right? But there's probably some diseases where you definitely want greater resolution. And so without that kind of resolution, you might not be able to even find whether the disease, exists or not, right? Yeah, any kind of, sorry, Maya, did you put your hand up? No, okay. Yeah, but yeah, like a great thought, right? Which is like, can we actually tackle these conditions before they kind of come, right? Like, is there any kind of potential from a preventive medicine side, right? Yeah. Any thoughts from you guys, like engineers?
I think from us, we're thinking about the agent side.
Yeah.
Where I don't know, there's a lot of ethical issues that can come in medical agentic AI, right? Because it's medical is like something that's highly dependent on human intervention.
Yeah.
But we were thinking of something in the lines of like like an autonomous surgery AI that could do simple surgery such as like the appendix surgery, and where it could have a model that could run robotics that could do the surgery automatically on its own based on like using like reinforcement learning and stuff like that.
Yeah.
But that comes at a lot of cost. What do you think?
I feel like you said everything. So yeah, we like. I feel like this could actually be done in the future, but for that we need people to actually start trusting AI. But for that we need to show some results.
Yeah, for sure.
It could actually be funny later in the future if that's like something that pops off. There could be like two options where you can either get surgery by a doctor that's going to be more expensive, or by a robot automatically that's more cheaper.
Yeah, it's like you have both options.
Yeah, but that could be like one.
Yeah, it's kind of like it's like the self-driving car thing. Like we have the options of like, you can go on the Waymo for like 10% more than an Uber, but like people will be willing to pay the 10% because it's you don't have to talk to anyone, which like people prices 10% higher for some reason. Yeah, it's quite interesting. Yeah. Any other thoughts from you guys?
We were kind of talking about like different information you could generate using AI, like potentially generating info for the patients like after appointments, because I think like if you have a 15-minute appointment, like half of it is figuring out what's going on. You don't really get to explain like what the plan is and why.
Yeah.
And like having an AI that's kind of tailored to you to explain that to you would probably increase like medication adherence quite a lot, and like actually make you more likely to come back to your GP and see them again if you actually know what's going on and why.
Yeah. I think that kind of use case is already being like created actually. Yeah, like in terms of being pursued in the even the Australian healthcare system. Yeah, very cool. I mean, like one thing that I'm seeing missing a little bit here, right? Like when we're thinking about this stuff is whether we're talking about things like world modeling or hypothesis generation as well. It's obviously more of a kind of research-based thing, right? But a big question is like, do these models understand more about the world than we kind of give it credit for, right? Like it's seeing connections that we might not understand, right? Because even on tests where you're trying to ask it to draw connections between two different fields, for example, it does quite well, right? Like it can draw like kind of these really abstract connections between different fields, right? It obviously doesn't mean that, like what it generates all is going to be true, but at least it's good for hypothesis generation, right? Like in terms of like potential theories that we might have missed. I like some of us have tried this though, and when you really get down to kind of brass tacks of like whether it understands a very specific field, sometimes it does end up hallucinating or just kind of making up stuff. But it has helped that it can now kind of read through literature, like quite a lot of the literature very fast, right? And so it can kind of draw links if you kind of guide it towards certain pieces of literature that is important, right? Like for sure is important, is kind of seminal. And so it can kind of do well under those circumstances. Okay, so kind of moving on. So the next topic of discussion is discussing what the most important trends in AI are today, right? So when I kind of presented something similar last year, a lot of the trends had actually changed, right, compared to this year, because there's been a couple of things that have happened. One is that we've ran out a little bit of data. So, you imagine the first models were trained on the entirety of the internet, right? And so it was kind of shocking that, how well the performance did, right? But of course, from an AI perspective, we've run out of data a little bit, right? Because the internet kind of generates much more slowly now, right? Rather than kind of 20 years or 30 years all at once. And so because of that, we've shifted a little bit from training the best AI models to now AI itself becoming a bit of a commodity, right? So that is, if Google or Claude or whatever releases a good AI model, kind of open source companies, usually from China, will follow on quite quickly, right? In a few months or so, they kind of get to that, that frontier, right? They kind of can catch up very quickly. And so because of that, a lot of companies have now shifted to building products, right? So OpenAI now, I think instead of focusing on building kind of the latest models, they're now trying to build products that they can sell, right? Because you need to justify a lot of those compute costs to investors. And so this has kind of shifted, how we think about AI a little bit. And with the kind of creation of things like reasoning, there has been kind of these trends here, which we'll talk about. But before kind of jumping onto that, we'll discuss first the scaling laws that now AI kind of follows. So the scaling laws were invented kind of when, or kind of discovered when AI was just first starting out. And it was essentially this concept that AI performance can be actually predicted based solely on these two factors here. So the first being compute, so that is how much compute you actually throw at the model, and that has continued to remain true. And then secondly is the amount of data. Now, unfortunately, we've run out a little bit of this amount of data, right, which is why AI has slowed down, but people are still continuing to basically throw as much compute as they can to an AI model, okay? So kind of very interesting. Now, the scaling law has been demonstrated across quite a broad range of, intelligence, right? So kind of 7 orders of magnitude of model size, and shows no signs of slowing down. Now, the problem is that as you kind of increase in model size here, the cost of this exponentially increases, right? So at some point, you can't just keep on increasing model size, okay? Now, what people have done instead is that they've actually shifted from training the model to using compute after the model has already been trained, okay? So that is, you train the model, you kind of freeze it, and then you give it more compute after it's been trained. And the way that that works is through reasoning. So that is, it thinks harder about how it's trying to answer a question, okay? So people are still kind of piling on compute. Now, yeah, this is basically what I was saying here. So in kind of the kind of takeaway of this slide is that better AI comes from more compute and more data. But unfortunately, we are starting to run out of this, right? So therefore, we have to add this, or we have to have some kind of architectural realization like attention, like something new, something different, right? It's kind of like a new type of transformer that's a lot more powerful and a lot more efficient. Part of the kind of motivation of this, and why some kind of the more fundamental AI scientists think that transformers aren't all the answer now, is that with a human, we see a lot less of the world and can learn a lot faster than AI, right? Which means that more efficient structures must exist, right? So we know for a fact that, like, humans don't see the whole internet before we kind of, learn how to do stuff, right? Why do these AI models have to see the whole internet before they can do stuff, right? Is a big question. And so much more efficient structures have to exist. And so a lot of research scientists are now kind of shifting towards seeing if they can improve the transformer. Now, these are some of the underlying trends that are kind of impacting us. So firstly, we're kind of running out of data. So this was how much data we were roughly using to train these models. And people are predicting that kind of roughly around 2028 is when these models will start to hit a bit of a ceiling in terms of how much data there is, right? Now, we obviously generate a lot of data as a human race, but it is not as fast as these models are growing, okay? Another important law that is still holding kind of 50 years later or 55 years later is this law called Moore's law, which says that the amount of compute that we have exponentially rises, right? So this is a logarithmic axis here. So if it's kind of a straight line here, it means that it doubles kind of every couple of years, right? And so the amount of compute we have access to is rapidly increasing, okay? And then finally, companies like OpenAI and Anthropic have predicted that they expect to spend a huge amount of money on compute as time moves forward, right? And so a lot of people have been asking whether they can actually get the revenue required in order to kind of invest, that much in compute, right? So some questions are being raised right now. All right, so I'm going to get you to actually spend some time reading this very important kind of lesson for the field, right? And you can just go to this link. We're just going to get everyone to read, and then we'll discuss what the implications of this are, right? So this is a kind of very important blog post, actually, that a lot of people think about in the field and kind of worry about in the field, right? And it kind of dictates and defines a lot of AI research as well. And so I'll give you about 5 to 10 minutes. You can just kind of read it, and then we'll discuss it.
Yeah. But what if the first time, like the AI had analyzed that data, it didn't extract everything it needed, so it like missed certain things? So what if it was to go back and see things from different perspectives to keep on using the same data but getting more and more each time it goes back?
Yeah, that's a good thought, actually. I hadn't thought about that. Like, how can you retrain using existing data, but on smarter models potentially? Yeah. But then I suppose you're limited, right? Like a big question people have right now is like, can you use these models to do like scientific discoveries, right? Like, for example, like, can you solve cancer or aging or something? But like, if we ourselves have never known it, like, can it figure it out by itself, right? In some way, right? It has to like rely on existing knowledge to do so, right?
Yeah.
But I don't know, like, can it be creative enough that it creates something completely novel we don't even understand, kind of thing, right? Yeah.
Does it have initiative or not? Because like often when you're interacting with it,
it
does it like it always like looks to approval for you to do something.
But that's because of how we train the models, right?
Yeah, so why don't we train it to like
to just do stuff by
itself? Just to do stuff like research whatever you want to like research and go as deep as you want to go and like if you have a question, explore it more and more.
I'm sure someone is trying to do that. I think it could be dangerous because it could like just realize, do you know what I mean? Like it just like a Skynet kind of thing, right? Like it just like finds a way to get onto the internet and just like distribute itself entirely or something, right? But yeah, you're absolutely right. Like what if these models aren't an assistant, right? Like they're ones that actually have some kind of agency and it goes back to its mission every single time and it like reassesses what it should do next, right? It's very possible to build a model like that, right?
Yeah, I think that's like a trend, especially in like software engineering, like agents to just iterate on code bases for like an extended like week or like hours to complete tasks. I'm sure we'll go through like there's like a bunch of benchmarks which show like the time taken for autonomously coding, and then it's just like been like increasing like rapidly. So like for instance, like hard machine learning problems that take humans like 4 hours to do, it can do in like 30 minutes of like iteratively testing, retrying sort of thing. So there is like a progress in its agency or like long-term capability.
Yeah, awesome. Okay, cool. Let's move on. So the kind of lessons of...
Sorry, just before we move on.
Oh, yeah.
There's a question in chat from Pahan. So what exactly do you mean by compute? Is that computational reasoning power?
So compute is just like kind of at the lowest level is just the mathematical like operations that you need to do to multiply the weights, basically, right, with the existing data. Like that's fundamentally it. Right now, like they found that GPUs work very good for it, right? And it's something that's like mass manufactured. GPUs were initially built for video games, as you know, a lot of you might know. And like the reason why they're good at doing them, like it's basically matrix multiplication, so multiplying like huge matrices, basically. And the reason why it was really good at that was because a lot of video game graphics required that matrix multiplication. So NVIDIA was just very lucky that they were creating a bunch of graphics cards for video games, and then AI needed the exact same mathematical operation. And so they're very efficient, right? But that being said, like there's lots of new ones coming on the scene that are trying to challenge NVIDIA because they can be a lot faster. So like, let me just think what the company is. Yeah, there's like this company, the name escapes me right now, but they have basically created a kind of, it's not a GPU, but like another computational power thing, which essentially can spit out 1,000 tokens a second. So 1,000 words pretty much a second, right? So when you try and use it, it's just, you know, you ask it a question and it's like, bam, like immediately the answer comes out, right? Which is just absolutely insane. And so there's like different new architectures that you can use in order to do so. So yeah, very exciting. And I don't know, like I'm like personally bullish on those kind of companies because I've used it. And it's like, once you see that wall of text come out, you can't go back to like how slow ChatGPT is, right? Because you're just like, oh, like I can just do that so fast, right? So very, very cool. I think the company, let's see, might be Cerebrus. Is it? Yeah. Wonder if there's like a demo or something. Oh, here we go. That's let me just replay that again. Yeah, this is a speed test. That's just insane, right? So can you just imagine like what you can do with that a little bit, right? Like you can't even comprehend how fast it is, but like an AI, if you have like an AI asking another AI to do something, you see how you can really speed up things, right? Yeah, and this already exists actually. You can actually use this and pay to use this. It's just a little bit expensive from memory. Yeah, they don't have the real rates here. Oh, here we go, $50 a month. That's actually not that bad. Yeah, but very, very cool. So you can do things ultra fast now. Okay, great question. So let's move on. So beta lesson is basically talking about how data and compute are the only thing that matters, right? So it's very much like what we're seeing in the scaling laws. Adding our own knowledge helps in the short term and is very satisfying, but it inhibits future progress. That's what this gentleman argues. And so he also argues that you got to add these general purpose methods. So like when ChatGPT was released, because it was trained primarily on language, it could not do math, right? If you ask it something like what's 2 + 2, it couldn't answer, right? Like it just got really confused. But we've since managed to add that capability, which is it actually will reach out to like a calculator, like Wolfram Alpha or something. It realizes it's a math question, will contact like a calculator, like an intelligent calculator thing, and then like outsource it to that calculator. If you ask it to do something, for example, like coding, it will realize that you're asking about coding, and so it will offload it to something that can handle code, right? So kind of like an interpreter. He also argues that we need to have things like attention or search or learning, which we have already started to add, right? So a big question right now is like, based on this blog post, what are other general purpose methods that you can actually provide to this AI? And we kind of discussed some of that yesterday. And his kind of rationale for it is the world and our minds are tremendously complex. And because we imperfectly understand it, we should not impose some of our assumptions on the AI. The AI needs to learn it itself and is probably going to do better than us. Okay, the kind of second trend that is becoming very important in particular this year is that intelligence is starting to commoditize, right? So this is a very kind of famous graph that we've all been seeing this year, which is that prices for running LLMs, right, have dropped precipitously, even kind of like the highest performing models as well as the kind of cheapest models possible. And they're all starting to converge to zero, right? And so the cost of running LLMs are decreasing kind of massively, right? And I think this has continued to go down kind of at this level here. Another thing is that the time to retrieve public information is starting to head to zero as well. So there's kind of a distinction between public and private information. So public information being something that's publicly available, right? So it could be stuff that's on Wikipedia, it could be like research that's on PubMed, it could be whatever it is. The time to kind of retrieve that information and kind of answer very hairy questions is starting to decrease quite massively, So for example, like say I'm trying to ask a fairly simple question, which is what's the population of Busan in 1983? So for example, in Korea, right? Before the internet, this might have taken me hours to figure out, right? Like you might have had to go to the library, get some books, on Korea, hopefully, right? And then see if you can find the population of Busan in that year, right? In the internet era, it would take a couple of Google searches for you to be able to do so. But with AI now, you could simply ask this question and it's very fast, right? Like they'll give you an answer which might be like 80 or 90% right within a few seconds, right? So kind of very cool. If you ask it a more complex question, how many couples got married in Busan in 1983, right? Pre-internet, you might have gone to, like a library in Korea or something, try to find like a book about how many couples got married, like some kind of record, right? To be able to find this out. But now it's getting a lot faster, right? You can ask AI and it will find the relevant information online for you to be able to get that information, right? And answer the question. So kind of very cool that we're seeing this. Now, there are a couple of implications for AI becoming cheaper and a lot faster to get kind of public information, right? So the first thing I've already mentioned, which is because AI models have now become commoditized, less and less money is being spent on actually developing the base model because it's so easy for other people to catch up with what you've done, right? So now AI companies must focus on real products to make a profit because as you can imagine, if everyone's just competing, the price of AI starts dropping to zero, right? Because it's just so cheap to do it. Publicly available information will become free and instant. Knowledge is democratized for fields with high intellectual barriers, but publicly available information. Now, this is a lot of stuff that we work on, unfortunately. So things like medicine, honestly, a lot of medical knowledge is not private knowledge, right? It's just stuff that's available on the internet, right? Even the research that we do is publicly available on the internet as well, right? And so therefore, knowledge will be available, unfortunately for us, for everyone else, right? Patients will be able to access more information. It's just easier for people to actually find out what condition they might have, potential treatments, where to get the best treatment. It's just really easy to do that, and they don't need doctors as much for information, this kind of information. And it's not just true for medicine, but it's true for things like law, where obviously all the laws are available just freely, right? Because it's kind of a public good. And it's the same with things like engineering as well, in particular coding, right? Because coding has a very strong open source culture, right? Computer science, right? Everything's kind of available. And so therefore, it's easier for non-coders to code. It's easier for non-lawyers to do law, and it's easier for non-doctors to do medicine as well, right? Now, they might legally not be allowed to practice medicine, but patients will be able to find information very easily. And then finally, there is a higher relative value of private information. Okay, so information that is like proprietary, secretly in companies or whatever, the value of that gets higher because that's kind of the edge that people have, right? Because public information is now so easy to access, okay? Any kind of reflections or thoughts on this? Any questions? Yeah.
Scale AI does, like they do, like they making the data private, and then like.
Yes, a little bit. So Scale AI is, for those of you who don't know, it's a company that labels data, right? So it's like you give it a ton of company data usually, and it will label it for you, right? So for example, like in the field of medicine, they will contract a bunch of doctors to label a bunch of medical information and give it kind of like the correct answer, right? Very valuable company. They kind of play in this interplay, right? Which is they will make private information more valuable because you can pay them to do so, right? Because a lot of data in companies, as you might expect, it's all over the place, right? It's kind of like, really messy. It's not organized well. It's not like labeled in any way, right? Because the company just creates so much information, right? Once you get into hospital, you'll see just how chaotic data is, right? But yeah, like Scale AI will help you clean up that data and therefore make this much more valuable. So those kind of companies are probably going to continue to succeed, right? So kind of very cool. Any other thoughts about public information being cheap and free and easy now versus kind of private information? What about like this fact that, fields like coding, medicine, and law might be massively kind of impacted? Yeah.
Because with the public event, you already see it like with like the widespread like disinformation campaign.
Yeah.
Disinformation.
Yeah.
We'd probably have like a responsibility, like at a government level, societal level, because to like ourselves try and disseminate this information.
Yeah.
So that people know like, oh, what's the best way of preventative medicine? What's this? And make it like widely available and like more easily accessible than like a third party trying to like spread disinformation like anti-vax stuff or like the stuff that happens during elections or whatever.
Yeah. It's very true. A big question I've been thinking about actually on that note is, like with something like disinformation, if people are getting their news from like Twitter or like Reddit or something, like maybe there's a lot of, like the stuff that is very inflammatory gets a lot of clicks, a lot of attention, right? But if it's like ChatGPT, like they don't see as much of the snake oil around, right? So is that like a better thing that people are asking, for medical advice from ChatGPT rather than like Twitter, right? Or I don't know. Yeah. Sorry, what was that? Okay. That's true. Yeah. I don't know, right? Yeah. Like, it would calm me more if someone was like, well, I was asking ChatGPT about this versus I was asking people on Twitter about this, like, my condition, right? Slightly better, Yeah.
That's all. Like, I think there was a case study of, I think, bromine poisoning. So I think maybe the next, difficulties or like challenges come in not the ease of access to information, but the relationship between like the thing giving the information and the person. So for instance, I think ChatGPT somehow convinced someone like an elderly individual that salt, like to get a low salt diet, they should use bromine as an alternative, and then they end up with like bromine poisoning. And like the thing is that information is available elsewhere, but it's in that compelling nature in the absence of like the surrounding context of the person, of how they will like interact with the information, that maybe the risks lie.
Yeah.
There's also like obviously like AI and like psychosis, which is like people having I think it's called folie à deux, which is like when delusions occur in pairs. So if you track conversations with AI, especially in people who are susceptible, you can see like the delusion scores, quote unquote, like spike up and stay high, especially for and it's also dependent on the LLM. So for instance, ChatGPT is bad at this, but Claude for whatever reason is better at like preventing folie à deux. So maybe like our responsibilities are how these people interface with like this other information, right? Which is like going to affect a lot more people than we expect.
Yeah. I mean, like, all this is to say that I think you have to kind of trust a little bit that there's at least a partially good actor in control of this, right? I'm sure you've seen like the Grok and, what Grok thinks of Elon Musk or something. Like it's almost like godlike level stuff recently, right? But like it's just interesting to see like it's how easy it is to manipulate entire populations now that you can kind of change the inner workings of the large language model, right? Because it's just, as you'll see in the prompt engineering exercise, it's just a prompt in the back end, right? And I'll show you a resource later, but you can actually see what the prompts are for these models, right? Like people have hacked into it and jailbroken it, and you can actually read very carefully what they say in these models. And it's pretty cool reading that, but you can see how, like if someone is a bad actor at one of these companies, they can insert in very interesting stuff, right? Very fun, very funny stuff that, starts to impact how everyone thinks about certain topics, right? So yeah, kind of interesting. Okay, let's talk about the third trend, which is verification asymmetry. So the way that AI is trained, it learns very quickly if you can verify a solution. Okay, so I'll just repeat that again. It can learn very quickly if it's easy to verify a solution. Okay, it learns very slowly if you cannot verify it is correct. Okay, so that is, if you tell it it's correct, then it'll learn very quickly, right? And unfortunately or fortunately, some tasks are naturally easier to verify a solution, as you might imagine, right? Some tasks are ultra hard to know if it's correct or not, right? Because AI needs the correct answer to learn, tasks which are easier to verify will be solved a lot faster. Okay, so we'll go through some examples of this. So a classic example is Sudoku, right? It is very hard to do Sudoku, right? It might take you like, I don't know, like half an hour, whatever, to complete this puzzle. But it's very quick for you to verify that it's correct, right? It's very simple in code to confirm it's correct. It's also the same with software engineering as well. So this was a recent Reddit post that I saw, whereby someone tried to one-shot a ChatGPT interface using Gemini 3, right? And it worked, right? And so it's historically been very hard to do this, right? It takes like months to build this interface, but it's very quick and easy to verify it works, right? You just click on a couple of buttons and you just see if it works the exact same way as ChatGPT, right? So it's kind of very quick and easy to verify. There's a couple of tasks which we imagine are very hard to verify. So for example, if I ask you which of these books are the best, right? It is very subjective what you think is the best book. It's going to require a lot of reading in order to verify that, right? It's the same with, Taylor Swift's latest album. Is this the best, right? Is this the best album that we know, right? It's very subjective, right? So we don't know what is correct and what is wrong, right? So it's very hard to train an AI. We can maybe tell it to sound more like Taylor Swift, but kind of in the general human race, right? It's very hard to say that this is better. Now, other tasks which are very hard as well is, if you create a new drug, it just takes a long time to verify it works, right? Because you need to do proper clinical trials, which might take years or decades, right? So very hard to verify. So for example, it will be hard to expect an AI to be able to verify that a new drug works because there's very few signals you can get. And it's the same thing with life, right? In terms of living what your best life might be, it's so subjective that it's hard for an AI to kind of verify and be trained on that, okay? So in order to have something that is fast to verify and easy to verify, and therefore easy for AI to learn, there are essentially 5 requirements. The first is that there has to be some kind of objective truth. So that is the vast majority of people agree that something is better or worse. The second is that it has to be fast and scalable to verify. The fourth is that there has to be low noise. So it can't be something where, it's so noisy that you don't know if it's correct or it's wrong, okay? And then finally, there has to be some kind of continuous reward. So that is, as it's doing a task, it knows that it's getting more and more correct, right? Because if it only learns right at the end, then it's very hard for the AI to learn what it did right and what it did wrong along the way, okay? So what are the implications of this? The first is that tasks which are easy to verify will be automated first, okay? So for example, things like software engineering have been much easier to verify because you can use things like testing, software testing, right? Just basic software testing to see whether it fits the specifications, okay? Faster measurement and verification will become very valuable. So companies will probably start to pop up in this field in order to speed up whether a task is correct or not, okay? And then finally, it is possible to exploit the verification asymmetry. And this is something that Google actually tried, where they had a very complex computer science problem, a very difficult to solve one, but it was easy to verify that it was correct. And so it managed to train an AI solely to solve that problem. Okay, and we're going to start to see some of those projects probably in the next year or two, whereby people use AI and the verification asymmetry to solve really difficult problems, but ones which are easy to verify. Okay? And so why this kind of verification asymmetry is so important is because jobs, honestly, which are easy to verify, will be the ones that kind of, get AI, AI-fied out of existence. Okay, so let's talk about what verification asymmetry also leads to, which is this concept of spiky intelligence. So because AI will find some tasks easier to verify than others, we expect AI to kind of be spiky, which is it's good at certain things and okay at some things and bad at a couple of other things, right? And so why that's important is a lot of people will look at this and go, if AI is bad at a certain task, then I better spend a lot of effort and energy learning how to do that, right? Because at least I will still be able to make money or make a living, right? But if AI is, if I'm trying to operate here and AI will become very good, then my job will be lost at some point, okay? Now, this is kind of a set of questions that one of the kind of top researchers at OpenAI uses to determine whether AI is likely to replace that role, right? So firstly, is it easy for humans? Is it digital? Is it easy to get or create data for that task? And is it easy to verify? And if the answer is yes to all of the above, they kind of expect that job will be taken over by AI, okay? So that's kind of how they measure it internally. Now, this is kind of another quote that I've seen, which kind of made me think a little bit. As someone who works in the AI field, I'm kind of very bullish about AI. But this quote says that those who don't work in AI greatly underestimate the magnitude of change and focus too much on the limitations of current systems, while those who do work in AI greatly underestimate the friction of translating strong AI to wide-scale economic impact. Okay, so kind of food for thought in terms of whether you work in AI or whether you don't work in AI. The kind of barriers that people do see and don't see are very different. So kind of very interesting. Okay, so let's move to a discussion for a couple of minutes about what these trends mean for society. So how you kind of think about things like scaling laws, for example, running out of data. What happens when intelligence is commoditized? So that is the cost of intelligence in some aspects becomes zero. So it becomes very cheap for certain parts of knowledge. What it means that there are certain roles which are easy to verify. And so if, for example, you work in one of these roles, you are likely to be replaced by AI at some point, versus roles where it is very difficult to verify what you're doing, right? Which means that AI is unlikely to take over your job, right? So I'll give you a few minutes to think about these questions. All right, guys. So what do you guys think? What jobs will we still have left? What jobs won't we still have? Yeah. Where will we put you? Which one does that fall in? Which one does that fall in? And what are you saying? Yeah. Anything we think like, will be maintained or preserved. I'll close that.
I think actually software could stay for a while.
Yeah.
Actually, contrary to what everyone says.
Yeah.
But I feel like there's just gonna be higher barrier of entry for people because a lot of people will have like because like the access of like knowledge and the access of like basically anyone's able to code now, right?
Yeah.
So like it gives a lot more value to people who knows their stuff like deeply without any help of AI and who can think.
Why is that? If AI knows like increasingly more knowledge, then why is it more valuable to have
because we can't always rely on AI where AI is always correct, right? Like there's like
even for something like software engineering where you can just like build the thing and then you're done, is it?
But it doesn't always like
it doesn't always work. Okay, so you mean like when problems come up, right? Okay.
When you try to build like scalable systems where it goes into the whole world, right? It doesn't its domain is really large. It's not like a simple, hey, can you create this app or like something like that. So it gives a lot of more value to
how do you develop those skills if you never, you know what I mean? Like as in the circumstances almost never call for it until something goes wrong.
Sometimes people just cracked, I think. but like there's like specific areas of like computer science where people have a lot of interest in it, like like DevOps or like full stack software engineering or
so kind of like the more esoteric folks who will suddenly be called for like this emergency that they've been training them for kind of okay, interesting. I mean, like the other kind of model to think about that is like airplanes, like pilots flying airplanes, right? When things go horribly wrong, it's not like I don't know if commercial pilots are that well trained for that kind of emergency, but like military pilots are kind of like weirdly good at that, right? So maybe it's like there's a subset of software engineers or something who still need to learn that kind of stuff, and therefore they're kind of called up when they need to, right? But I don't know why. Like I know, like with military, it's like it makes sense they need to learn like really complex situations. But would it be like a military software engineer or something that happens to be very good at
if we take a look at like the previous like Cloudflare event where I don't know, there's like rumors where because like they don't understand like they use Rust, right, for the backend. And there was like basically they use the wrong function to they use the wrong function because they didn't know how the function works in the back in the like how the Rust actually unwraps the function. So it doesn't work in a scalable way, and that crashes the whole internet. And yes, it's something like that. Where you have to like learn something really deeply. Like because if we look at like ChatGPT, because it learns on prediction, right? And learn on like something that everyone basically does, and like it will create something that basically is similar to that. If that specific case is never done before, that could like pose a problem in the future, so something like that.
I mean, like they're already, I think, some of the Microsoft CEO, Google CEO were asked like how much % of code being written in the company is like AI generated, and it's gone from like 0 to 30% in 1 year, right? So or like maybe even higher at some of the companies. So it's like, and you ask an engineer like if they understand anything happening in their vibe coded project, and they have no clue what's happening. They have absolutely no clue what's happening inside, right? So already like 30% of the code at Microsoft or Google is like no one understands really what is happening in the code, right? Like if something goes wrong, they're gonna take ages to like figure out what's happening, right? And could be written with all kind of weird structures and that kind of stuff, right? So yeah, very interesting. What about medicine then? Like what do we think from a medical side? What jobs are sorry?
Because some of us believe that like the human aspect's like quite important. And that like personally we would want to see like a human for certain things like psychiatry or like people that understand what the human experience is versus an AI which perhaps doesn't, even though like it seems like it does, but it depends on like how comfortable you feel on that issue. So I think it's different for each person.
So if you guys could choose like any specialty as soon as you graduate, what specialty would it be? Like what specialty do you think is most protected from AI? So what was that? Politician. Just gone to politics of the hospital.
Because
good question.
Because we think
right? Then like you have to make a bet, in 5 years or something, right? Like you have to choose a specialty and you think that it's going to be the most protected, right? And you're going to see the rest of your colleagues like, get replaced by AI slowly, right?
Interaction where it needs like
I don't know. Yeah, maybe. I don't know. Yeah.
I think like for me, like what I'm betting on, like what I want to do is like GP, because at least it like affords you like enough like generalizability where it's like medicine across like a lot of domains. So it's like if you need to like
shift if you need to.
you can quickly pivot. Like maybe like rural generalist, because like it's like the same thing as GP except like
okay.
Like you require more.
Interesting.
Yeah. Also, like the ability to embed in like a community as a doctor is probably something that's going to be hard for AI to do.
Yeah.
Especially in like rural, close-knit communities.
Yeah. Very true. Yeah. Any thoughts? Yeah.
I mean, we haven't really talked about.
Yeah.
I was trying to argue that being an anaesthetist might be the most secure, like a very secure job.
Yeah.
Just going forward, just in the sense that there's a physical aspect of like, doing the procedures. You need to be present, taking patient vitals in a way that you're probably going to become like an AI overseer as well.
Yeah. So we're discussing this concept of watching over a bunch of AIs, right?
Yeah.
And kind of like that being a job a little bit, right? Like, what do you think of that kind of role?
Definitely. I mean, right now the joke is anesthetists are just on their phones in theater, which I can say is very true.
Yeah.
But
I mean, you're a bit of an AI overseer though, if you're reading through transcripts, right? Aren't you just literally reading through the work of AI, and then correcting it? Yeah.
I am a very amateur AI overseer, but I think that's probably the way my career in medicine will be.
Yeah.
Just getting AIs to work for me.
Yeah.
So maybe, who knows, I might become an anesthetist. Right now it's you can only do one case at a time as an anesthetist. But it might be interesting to see if you can do manage more, do your physical procedures and then, go to the next patient.
Yeah.
You can be a lot more efficient and then have AIs which are able to like let you know if like there's a warning, and then obviously you go. It might be able to alert other anesthetists that they need more support. And to come visit the patients.
Yeah.
So I think that's an interesting idea. But obviously, as I learn more specialties, I'll see what's more protected, I guess.
Yeah, very interesting. I mean, is there any task in medicine that we think is very difficult to verify? So like you have no idea if the person's doing a good job or not? What was that, sorry?
Like a history from a demented patient.
History from a demented patient? Yeah. Tell us more, like.
Yeah. Oh, sorry. Can I? Sorry to interrupt your class. But I'm a geriatrician for those who don't know. But basically, when you interact with older patients, there's a lot of, I guess, subjective. You do rely on a bit of your own intuition, where you're not sure if what they're saying is 100% accurate. The history that they give might be influenced by a bit of cognitive impairment. It could be influenced by their mood. It could be influenced by just fatigue, and they might over or under-report certain things. Their time frame that they remember might be very different from what their next of kin would remember. So they would downplay certain symptoms, whereas the next of kin would be like, no, this has been going on for much longer. So when AI comes to take that kind of history, they'll be so confused what's right, what's wrong, because there's clashing input. How is it going to decide what's the more accurate? Well, it could, but then not all collateral history is good as gold as well. Some family members have their own secret agenda that they want to push onto the patient, and then you end up becoming, a detective for elder abuse. So in that case, maybe the elder person was right, but the collateral history was wrong. But then because of ageism, you might end up deciding to trust the child who, I have heard of cases where the parent, the elderly patient, gets thrown into a nursing home because everyone, including the GP, decided to certify they have dementia and they don't have capacity. But actually on a second, third, and fourth opinion, perhaps, then they realized that this man was actually being abused by the daughter, who somehow managed to get the GP to sign that there's no capacity just to get all the money. So these things exist. And if you don't have that intuition, that sort of clinical judgment or the clinician's judgment based on body language, based on the unspoken things, based on that, tremble at the end of their sentence, I think that kind of stuff is a lot harder for AI to detect, because AI might be good at doing the general stuff, but then there's a lot of nuance when it comes to the unspoken stuff.
Do you feel like AI can detect things like hesitation or like, fear or something like that yet? Or you feel like it can't? And can it eventually?
It might.
Yeah.
But they're going to be like, say, if you see an elderly person taking their time to say something, to say a word, what differentials come to your mind? There's actually still quite a lot of possibilities for why that's happened. It could be that they were distracted by a spill on the floor, or it could be that that day they took an extra beta blocker accidentally, or it could be that they do have dementia, or it could be that they were thinking and distracted by a depressing thought that just happened in the previous conversation where you were talking about sending them into a nursing home. Or it could be that they're just, having a personality disorder. There's so many reasons. So I think it'd be hard for AI to, at that point in time, decide which reason it is and decide how to trust.
Yeah, very fascinating. Any additional thoughts on that? Thanks so much for sharing. Okay, so let's keep moving forward. Yep, running out of battery, am I? Okay. So I was going to add these as discussion points as well, but we actually might just keep on moving. There's been some interesting kind of papers on AI, and you can take a look at this afterwards in terms of how AI is performing compared to doctors and what it might be missing, what it might be getting as well. But yeah, I'll leave these for you to kind of peruse afterwards if you're interested. All right, we're going to have to skip this bio break. Now let's move on to the